Hey everybody, I'm Zach.
And I'm Jesse.
Today on Disruptive Investing, we're going to be talking to Jim Metropoulos. He's the CEO and founder of Blue Box.
Blue Box specializes on cleaning air conditioners.
Yeah, it sounds super boring. I know, you're probably like, I didn't even know you had to clean them. We thought the same thing when we heard about it, like, big deal. What does this have to do with anything? But then our minds were blown. And I think if you take a few minutes to watch this interview, your mind's going to be blown too. Jim, thank you so much for meeting with me today. It's a really hot day out today, and that's very apropos because you are into some really cool tech here that has to do with compressors. So we have with us today Jim Metropoulos, the CEO and founder of Blue Box. So tell me, what is Blue Box?
Thank you. Yeah, you know, Blue Box is one of those simple innovations. Basically, it solves a major problem in HVAC. And how I came about this was really almost actually by accident. I didn't set out developing Blue Box to solve this problem in HVAC. I actually originally designed the system to it was a way to how to clean big giant systems in oil refineries and power plants. It was a way to do chemical cleaning with using a fraction of the water and chemicals. And the early version of it was a system that was the size of a suitcase. And with that system, I could fill a 3-story house with foam. And I'd mix in hydrochloric acid, sodium hydroxide. And it was a way to do these. And what I was going after was how to clean big, giant industrial systems.
Okay, like what?
So think of it this way. The world is based on heating things up, cooling things down. And between that, it's all heat exchange. All right. Okay. And if you think about that, like an oil refinery, for example, is you look at a refinery as these massive systems. Their job is how to heat up oil so you could get gasoline, diesel fuel, jet. You have distillation process. Okay. Now, I grew up in Southern California, in a beach town called Manhattan Beach, and right next to Manhattan Beach is the El Segundo refinery. And I would drive past this refinery all the time, and I look at these systems. And one day I read a book, and it was explained how much energy just to refine fuel, how much energy it consumes. So there's 150 oil refineries in the United States. Those 150 refineries consume, I think, it's somewhere around 8 to 9% of all the energy in the United States just to get gasoline, jet fuel, etc. Wow. Because it's all about heating it up and then cooling it down. The origins of Blue Box was, I started thinking about the problem of climate change really seriously back in 2008 during the financial crisis, where I had noticed all the solar and wind projects and all the clean tech projects basically were getting thrown out the window. Everybody's in crisis mode, and those were the first things to go. And I looked at that, and at the time, wind and solar were very expensive. But that was kind of like the main drivers of like, all right, how are we going to address climate? And all of a sudden they got, because of the financial costs, et cetera. And so I looked at that, and I'm like, if you really think about it, carbon emissions is literally wasted money that's going into the atmosphere. Mm-hmm. And I started thinking about, if you could make carbon reduction profitable, you make carbon reduction possible. Like, it's all about efficiency. Right. And this led me down the path of Blue Box in the first system. Like, if I could develop these innovations, and I looked at refineries, and the thing with refineries is that they had not ever changed how they operate their facilities or in the cleaning of equipment since the days of J.D. Rockefeller. Like, it's all run to failure, pressure wash. Because what happens during, because you have these massive heat exchangers, and they build up with calcium, and they build up with hydrocarbon fouling and all this stuff, and it inhibits heat transfer. But they keep on running it until it's almost dead. Why don't they stop every now and then and clean it? Well, the idea they do is, but then it's a major plant shutdown.
Oh, so the whole thing has to stop.
To shut down.
Oh, okay. So it's inefficient, but it's better to do it that way than to keep stopping the plant.
Exactly.
Okay.
And so I started thinking, I'm like, well, you don't have to do the entire plant, but what if you could find the key choke points? And is it possible to clean these things online and improve the process? Also, so chemical cleaning is widely used in refineries. Millions of gallons of water and waste is generated. And I was like, there's a market there to, it wasn't just about carbon emissions, it was about just overall sustainability, but improving production, improving process.
And this is what, 2010?
2010 is when I first started designing these systems. Okay. Fast forward, in 2015, I actually was walking a plant a General Motors plant, of all places, with a engineer, and looking at different systems like cooling towers, scrubbers, big giant systems. And we're walking past a giant air handler. And these, in the auto plants, they have these systems. So an air handler, when you're talking HVAC, it's in big facilities, they're big giant steel box. You have a giant blower is moving air through the coils, the heat transfer coils, and you have chilled water going through it. And, warm air hits cold, metal, and, you get cold air and you get refrigeration. Now in auto plants, they, air conditioning, a lot of people don't know, is, it's fundamental to the manufacturing process in cars and semiconductor chips, because you're controlling humidity, temperature, all these little factors. So GM had these massive air handlers. The systems are 20 feet high, could be 30 feet across, 2 feet deep, big monster systems. And we're walking past this system, and this engineer goes to me and goes, "Hey, can you adapt your process to clean the coils in my air handler?" And at the time, I knew nothing about HVAC. I knew nothing about coils, nothing about air handlers, and I'm like, "Sure." How hard could that be? I look back at it now, and it's comical how little I knew. I just jumped into it, no fear whatsoever. And I looked at the system, and I knew there's going to be a bio issue going on. And
what do you mean a bio issue?
So in big industrial systems, a big problem that they have is biofouling. And this is where bacteria or fungus will grow. And this could be in water systems, and this can be in all kinds of equipment. And what happens when bacteria and fungus grows, they form what's called a biofilm. If you ever see a snail that goes along the ground and that trail leaves behind, that's a biofilm. Now, biofilms it's like a thermal blanket. Once they're on a piece of metal, like on a piece of heat transfer equipment, and you can have a piece of metal and not even be able to see the biofilm, and it is a thermal. It will inhibit heat transfer 5 times greater than, say, scale formation. It's like a gelatinous type of slime.
And that is the whole point of those fins, is to transfer the heat out of it.
That is why like in all HVAC systems, whether it's your home or whether it's a big giant air handler in General Motors, it's the same design. You have fins. And then you have these tubes that go through it, and they're transferring heat. So you have cold water, and it's making everything cold. And then air goes through it, and the air molecules are bouncing between the plates. And then it's 80 degrees, goes through a chilled water that's at 45 degrees, comes out at 65 degrees or 50 degrees.
So I'm seeing the problem now. So basically, as water condenses on these coils, you get what life likes, which is water. Right, yeah. And so it can live there, and now it's basically making this blanket over everything that we're not even pretty much aware of.
Absolutely, and this not only causes a problem with heat transfer, and I'll get into it a little bit. It start talking about indoor air quality. All right, and it causes a whole lot of problems.
Really,
but so when I first looked at the problem, though, I knew there was bio because I could see condensation. Wherever there's condensation, just from my experience, what I was doing before, I knew it was going to be, and the fins, they're aluminum, they're soft metals, so you can't use chemicals.
So you just went to the hardware store, got yourself a pressure washer, and took care of the problem.
Which was that easy. And it was interesting because I didn't know anything about the problem except that I knew I was going to use enzymes. And I had started pioneering how to use enzymes to remove down these biofilms, because with a biofilm, it's let's say you have a pipe and there's a lot of calcium in it, and then there's a lot of bio on top of the, because that's where the water's at. You could throw hydrochloric acid on a biofilm, and it's not going to do anything. It's chemical resistant.
Oh.
So you got to remove the biofilm first in order to get to the calcium, and then hydrochloric acid will react with the calcium, and that's how you remove scale buildup. And now, the problem is with hydrochloric acid is it'll eat through the metal. So you got to be. It's a really careful game. And I really was pioneering how to make it very safe, very controlled, and very effective by first removing the bio. And you do it in foam phase, and it was all these things. Anyhow, when I looked at the problem, I go, all right, it's going to be enzymes. We're going to inject enzymes into the coils that'll digest everything out. Okay. And it'll be safe for the metal and all this. The problem was, when you work on big industrial equipment, there's a thing called lockout tagout. And lockout tagout is a safety protocol in engineering where you turn off the power source, put a lock on it, and when you're working on big giant industrial equipment, you never want it live. So you shut it down. So I'm in there and I have my blue box at the time, which was much bigger because it wasn't designed for this application. And I'm shooting foam into it and I'm like, son of a, how the heck do you get through this coil?
Because it's off.
Because it's off, but the coil this coil is deep, okay? And the fins are like very densely packed. So it turns out like a coil in an air handler, it's designed so that only air molecules get passed through and nothing else. Whether I was shooting foam or if I decided to try to pressure washer, what happens is the energy will hit the coils and it absorbs. And these are vertical systems, they're vertical slits, and it goes down, it absorbs in, and then the moisture will just go straight down. You can't penetrate that coil. And that's the problem with coils, is since the invention of the HVAC system over 100 years ago, there's never been a way to clean these coils, ever. And I didn't know this at the time. Like I said, it's a, this engineer had asked me, hey, can you clean my coils or adaptive process? And
wait a minute, so I'm a big a casino, let's say, and I invest in HVAC because I need it. I'm in the middle of Las Vegas. And you're just telling me that every year it's just going to get worse, like my HVAC system?
All built, whether it's a casino, a hotel, a hospital, a school, or your home. Every system does the same thing. It's when you build a brand new building, all right? Now, almost all buildings, big buildings, especially facilities, have designed into them 40% more excess HVAC capacity than they actually need to keep that building cool.
Because they know it's gonna...
Because they know there's a problem.
Oh my gosh.
And what happens is you have a giant air handler and it's moving, like in the GM case, 75,000 cubic feet per minute of air, per minute, okay? That's a massive volume of air. That's enough air to cool 75,000 square feet, all right? Now a GM plant is massive. One plant can have 100 of these systems. It's really, on a big scale. But this problem of coils, and it's interesting because when I first, to go back on, I'm in this air handler with, and I had the GM engineers watch me almost laugh because they knew, like, this is not going to go on. It's almost like they're setting me up for failure, kind of thing. Then they
probably say that to everybody.
They're like, hey, solve my coil problem. No, it's like the Gordian knot. Hey, kid, why are you? We got a little knot problem here. You think you're going to tie it? And so I'm in there, and I'm like, God, how do you get through this coil? And I didn't know at the time. The answer was you don't. No one does. And so then I'm sitting there, and I'm like, you know what? Why do lockout tagout? Why keep the system off? And because I had dealt with foam and, with Blue Box and the refiners and stuff, I could shoot foam a mile down a pipeline, all kinds of nooks and crannies. So I know how it flows and, how it goes through systems and all this stuff. So I knew exactly what it was going to do. Use the airflow. The foam is nice and light.
Oh, basically let the air handler
suck it in.
How do you get around the lockout part?
So all right, so I come out of the air handler and I go to the engineers and I go, hey, do you guys mind
if you just keep it running?
If I could turn the air handler on and clean the coils while the system is on? And these guys looked at me and they're like, no way. And it was I'm not kidding you, it was an hour debate. We're in this massive mechanical room and luckily we're in the far side of the plant where no one was at. And these guys are like, are you crazy? There's no way. Because it goes against counter their training. Now, the thing is, it's a safety protocol. You never want to be around moving mechanical parts, but in an air handler, all the mechanical is you have the motor and the blower and the belts, and then you have this coil. Well, that coil is a wall.
I see.
And the air is moving through, but I can't get sucked through that coil. Right. I'm protected.
Right.
And I go, guys, there is no danger. I'm protected. And it's 75,000 CFM of fresh air coming in, so it's not an enclosed space. Right. All this, but lockout tagout was applied to these air handlers because it's part of like when you're let's say when they started building oil refineries and these big, they have lockout tagout for very good reasons. All right, but engineering is a lot of times you just apply best practices, and it just became ingrained in the how everybody did everything from the turn of the century, quite frankly.
So you come along with basically first principles, like why are we doing it that way?
Exactly. It's like just because it's always been done that way, it's like, listen, I have to get through that coil. I know how to get through that coil. It took me 15 minutes to solve this problem. I knew, once I saw it and I was shooting, I got frustrated, and these guys are watching me, and I'm like, I'm at GM. I'm really excited to be there because I wanted to try to, impress these guys. And then, I'm like, I know how I get solid. So it took about a lot of debate, and I finally go, listen, luckily this air handler was really big, and the motor and the blower and everything were, in these systems, were about 15 feet away on the other side. These are, so there's plenty of space. And I go, guys, they're going, well, it's going to fly all over the place. The foam's going to go in, and it's going to get in the ducts and stuff. And I go, no, it's not. And I go, let's do a small sample. And we took a little section of a coil that's, I said, massive. Let me show you. And I shot it, and it did exactly what I knew it was going to do. It just went right through the coil, and it popped through the coil, and it was very controlled. And you can control the foam. The trick with foam is how you inject it in, you can control how it comes out. So finally, these guys, probably because it was basically a dog on a bone, I just would not give up. They finally relented, and they're like, all right, just, you kind of did one of these, and they're like,
go for it.
Just don't tell anybody, will you? So it was interesting. So I did the entire air handler by myself, and then after I was done, and I'm like, all right, I think I got this thing pretty clean. And mind you, then at that point, I really did not know what the heck. I was just trying to get through the coil and just see what happens. So then they did measurements on the system. Now in HVAC, you measure airflow, okay? And the coil creates what's called a airflow resistance, or a pressure differential. So you have a blower here, air's coming in, and that coil has a pressure differential. Now, the dirtier that coil is, the greater the restriction, the greater the differential. So the rule of thumb, just a rough rule of thumb in HVAC, is a 1% reduction in pressure drop typically equates to a 1% reduction in the energy consumption of the motor, or technically the brake horsepower of that motor. So they took their measurements, and I delivered a pressure drop, or reduced the pressure by 40%.
Wow.
And it was funny because at that time, I didn't even know what a pressure drop was. Like, I knew what a pressure drop was, but I didn't know the magnitude and the.
Wait, so the motor's working 40% less hard
to move the same volume of air.
Wow. And just to step back for a second, because it's working hard, I assume day in, day out, it's more likely to burn out.
And this gets into the problem of coils. Now, the thing is, because there's never been a way to get through the coils, once it starts fouling up, this system is always running under load. And it only gets worse and worse and worse over time. It runs to failure. Okay, at some point, and usually in commercial systems, after about 20 years or so, but it could be as fast as 5 years, depending on your environment and how, a bunch of factors, all of a sudden these things plug up and you got to replace them. Now, to replace a coil like that in a GM plant, that's a $250,000 check.
Wow.
Okay. And so and on a massive system that's 75,000 CFM, because that motor, I believe, was a 80 horsepower motor or 75. It's a big motor, all right? Big energy, moving big air, and a 40% drop. These engineers, their jaw hit the floor. They're like, what the heck did you do?
Yeah, what's in that magic foam?
And I'm like, what the heck did I do? And it was really funny about the story is that, I'll give you an idea of how little I knew about HVAC. I think I mentioned I'm from Southern California, and I'm from a coastal town called Manhattan Beach, all right? I just recently moved to Dallas. I moved to company headquarters last year to Dallas, but prior to that, I have never lived in a house with air conditioning. Serious, because when you're on the beach, I'm literally right on just a couple blocks from the beach. It's so mild year round. It's one of the few places really, around the world that you actually need air conditioning. Unfortunately, that's changing now. It's funny, a lot of the coastal communities in Southern California, people are now starting to put AC because it's getting hotter and hotter during the summertime. But growing up, never grew up in a house with air conditioning. I originally was not associating this system with big giant HVAC systems in buildings and hotels and hospitals. And it was kind of funny because 2 weeks later, I was in Charlotte, North Carolina, and I was talking to the building engineer about their cooling towers, because I had created this process using Blue Box to clean the cooling towers outside. And I was at the Bank of America's headquarters. It's the tallest building in Charlotte. And I go to this chief engineer and I go, hey, by any chance, do you have any air handlers in your building? Because I just knew the vocabulary. And he looked at me and he goes, I have 100 air handlers in this building. And I looked at him, I'm like, oh, okay. This is the HVAC system. Like, this is and what I was at GM, I was actually in their paint booth operations, because I thought this was something specific for paint booth operations. And, it's like, I'm in a big industrial plant, and I said, I just don't know HVAC. And my mindset is not there at all. I know cooling towers.
Are hidden away, right?
They're hidden away, they're backroom. And this is kind of the thing, like, listen, 99.9% of the world's population has no idea what an air handler is, a coil is, or these.
I just want to stop you right now for our viewers and just fast forward to today. List off some of your clients today.
Yeah, we started commercializing Blue Box in 2016, and so today our clients include General Motors, Chrysler, MGM Resorts. We do half the Las Vegas Strip, so like the Bellagio, Mirage, Mandalay Bay, MGM Grand, Luxor, Excalibur, Tyson Foods, we just did their corporate headquarters, Baylor University, Rice University, UCLA Medical Center, Johns Hopkins University, in New York City, SL Green's the largest commercial real estate owner in New York City. We've done the Chrysler Building.
Yeah, so the list could go on.
I literally could go on, and it's crazy. It's in a short, like I said, we started commercializing, and Blue Box right now, we have 80 people, in the company. We now have operations in techs and sales in, say, Southern California, Las Vegas, Dallas, Houston, Denver, Oklahoma City, New Orleans, Miami, Orlando, New York.
And you're telling me that in 2015, though, you barely knew what HVAC was.
Barely.
This to me is so comparable to Elon Musk, because Elon started a rocket company and didn't know, and he wasn't a rocket engineer when he was born, right? He just knew that he could do it better. Yeah. You saw this problem and you said, I love it. You said to the guy who asked you, can you fix this? Yes, I can. Yeah. I just really admire that in CEOs who are naive enough to say yes. Because instead of you going, well, let me look into it, you said, yeah. And that is the first step to solving a problem.
Yeah, and it was interesting, because even though I didn't know, I didn't know the system, and I didn't know the magnitude of the problems, but I had a fundamental idea of what was going on in the system. And you just look at it and you're like, all right, I knew these guys have a problem. And I started thinking about it. I'm like, all right, you just start breaking it down into pieces. But it is very similar in that, like, I started, going to first principles. It's like, well, why do lockout tagout? Now, it's a safety protocol. My mental checklist went, well, am I in danger? Is there any equipment in danger and stuff? I'm like, no, I know exactly how this is going to go. And so it was a control, and and I had spent, the previous, few previous years involving getting into, big industrial equipment. So I was used to the problem. I was perfectly conditioned to solve this problem in the way I did. Now, what is really funny is that I'm not an engineer. I'm UCLA political science. But it's interesting because if I was a trained engineer,
you may not see the problem.
I would have not have gone against counter my training, which is, keep equipment off, and things like that.
So I have a question.
Sure.
This works well on big air handlers, but there's air conditioners in cars, they're in homes, they're in windows. Does this work on any coil?
On anything. Any kind of coil, evaporative coil. So evaporative coils is what the refrigerant goes through and you get cold air. Then you have your condensing coils. This is where in an HVAC system you have a compressor. It's compressing refrigerant gases and you create heat. You got to expel the heat. So it has to go through a condenser coil to expel, and then you're ready to create the cold. All right. So condensing coils, this is the blue box system. When our technician,
wait a minute, we're looking at it like
this is the system. This is
your technician shows up with this box.
My techs will roll in. So the system itself is built. Everything's inside the thing. There's no electronics. It's all run off. You hook up a small little air compressor. I mean, a tiny little thing. It's quiet. And all in, this thing weighs maybe 30 pounds. Now, what is great about this system is that you can do the largest of air handlers to the smallest of what are called fan coils, like in hotel rooms. So we have a small little fan coil that's, very small. And, these systems are never cleaned because if you bring a pressure washer in, you're going to flood the place.
Right. Wait, so let's go back to, you had said earlier that there was a problem with biofouling.
Yeah.
Is this what we're talking about now, like in this room we're in now?
Yes. And so what is interesting about the problem with coils is that think about the HVAC system as the lungs of the building. All right. All the air in a building must go through these coils, and that air is recirculated. So in any given building, just by even code, it's 90% of the air is recirculated and 10% is brought in as fresh outside air. All that air comes in, it's mixed, and it's constantly recirculated. And you have, let's say in a big high rise, you have 50 or 100 air handlers, and they're distributed, and the air is going through and is circulating through everything. And what happens is then, they start getting fouled up. Now that does two things. One, it starts inhibiting airflow, all right? Which means that even though you're supposed to be bringing in 10% outside air, you may only be bringing in 5% outside air, 3% outside air, because the coils are choked up and not much. What happens, imagine a building, you have a lot of people in it, and everybody's breathing. They're exhaling CO2, carbon dioxide. And that air is not, the molecules are not displacing those molecules. And all of a sudden, you have these buildings where the CO2 levels start going up. This is the key source of indoor air quality. Now, if you ever walked into a building and it smells funky, what you were smelling are the coils.
Interesting.
Now, you know what has the worst coils in the world that you'll find consistently are hospitals.
Wait, what?
Hospitals. Because a hospital is a microbial-rich environment. It's where all the sick people are at. Now, all that air is recirculated, okay?
Yeah, but you hear them talk about Hepa filters all the time. Like, don't worry, we have Hepa filters.
So, Hepa filters, I always look at Hepa filters as, think of catch and release, okay? So, Hepa filters are really expensive. And because they're so expensive, they leave them in there for as long as they can. They can leave them in there for up to 2 years sometimes. Now, bacteria, and they typically will put the Hepa filters downstream of the coils. All right. Now in filters, there are always these box frames, and you have to install them, and then you pull them out and you throw them away. And what happens is they'll capture bacteria and fungus and whatever microbes, and you have positive airflow pressure, and it doesn't kill them, it just captures it.
I see. And
they start moving through the filter media. Then they'll jump back on the airstream downstream, especially if they're not being replaced out. Now, also with HEPA filters is that there's always little air gaps in between. And so, and the higher the filter rating, the HEPA filter is, the more bypass there is because there's more pressure. It's like, imagine you had an airline and you have a pinhole leak in it, and if you have moving air through it but very little pressure, nothing comes out. But it's on 100 PSI, it starts coming out. So Now, the thing is, what happens, all the coils basically are a perfect breeding ground for microbes that exist in, and they start taking root.
And no one's ever cleaning them.
And well, they're cleaning the coils. These guys, the facility, engineers, they're doing all they can to try to keep them clean. The problem is they're only getting the outside 5%.
Oh, I see.
They can never penetrate that coil. So when they pressure wash, you say you only get 5%, these things. And
it looks shiny.
It looks shiny. It looks great. You go into air handlers in a hospital and they can look like you can eat off of them and everything like that. But when we go in and clean them, all of a sudden you'll see the foam just doesn't go through. It's these massive blockages, inside them. And so Blue Box, by solving this problem, it's the first process ever that makes it possible to deliver perfect surface area coverage throughout that coil. And then the enzymes go in and they start digesting out all the biofilm, which is the protective nest for the microbes and everything gets pushed out. That coil is cleaned, it's disinfected, and it fully restores the airflow. So then you have the ventilation that goes through it. It solves all these different problems. And it's interesting because then you have the energy efficiency gains. So we just did a project in Australia. I just set up operations out there in January. And there's a major hospital group where, give you an idea of the efficiency gains that we get, or the effect we can have. So this hospital cleaned all the coils, great pressure drops, everything, all the airflows being improved, the heat transfers, everything. So this hospital had 3 big chillers. And the chillers they're typically in the basement. This is what creates all the cold water. So a building is like a giant circulatory system. So you have all this water and it circulates through all the coils, goes back to the chiller, and it's a closed loop system that creates the cooling. Chillers are think of it as a massive V8 engine. I mean, it's a horse. It's where all the big energy is being consumed to create all this this water. After we had cleaned this hospital, chiller number 3 just shut down, completely went off, and the engineer was like, oh my God, what happened?
Wait, it wasn't needed, or?
Well, it was funny. He was like, what happened to this thing? And he's trying to figure out what's going on. He brings in his mechanical guys, the manufacturer. They look at it and are like, this chiller's fine. It just is not needed. The load is not needed.
Wow.
So what happens is all the air is like, if you have a box and you have the coil and say you have all this airflow going through it and it's fully fouled up, so a quarter of the air is coming out. All right. Now, because it's fouled, you're not getting the air molecules are not touching the metal. So you're not getting any heat transfer. So not only are you getting a quarter of the air, but that air is, say, 80 degrees outside and it's coming out, like say 72 degrees, the exit air. Well, that room is going to be about 75 degrees. It's not going to get cool. You're not reducing the load. Then, we come in and everything is restored to brand new. So now you have 4 times more airflow, and that air is 60 degrees exit air, because it's all of a sudden this room gets cool real quick. Now this thing is shut down.
Right.
Everything gets cooler, faster, easier. It just slows down.
So I just want to look at the big picture here. So basically, we're building out our whole infrastructure of cooling that's just going to get worse from day one.
Yeah.
And basically use more and more energy every year.
Yeah.
And we must be talking a lot of energy.
So think about it this way. Our ability to control our indoor climate is one of the major drivers of climate change. It is affecting our outdoor. The amount of energy that goes in, and people don't really think about how much energy goes into creating cooling. Every modern building in the world is outfitted with an HVAC system. Every single one of those systems is running at some level of inefficiency and poor indoor air quality, and it all gets down to the singular choke point of this inability to clean the coils. And we assault in a building, let's say, in this hotel, where that we're in, probably up to 70% of all the energy in this building being consumed is going to the HVAC system. Up to half that energy is being wasted right now because the coils are dirty.
Wow. Okay, so I want to switch to investor hat.
Sure.
So when I hear things like this, I think like, I want to invest in this company. You're basically a startup. I mean, if you started in 2015, you're probably on that road, right?
Yep.
So talk to me about funding rounds. Talk to me about how investors could possibly get interested in.
Yeah, so it was interesting because I started commercializing, Blue Box for, and I actually set up the LLC as Blue Box Air. Like the stuff we're doing, the industrial, I was actually another company. I just basically shut that down. We did a massive pivot. I was like, guys, this is it. Everything is all about coils, and we're never going to look at anything other than coils. This is our killer app, and it's a global, and and I knew it. So 2016, our first year revenue was about $200,000. And it was interesting because my first client was the Bellagio in Las Vegas, right out of the gate, and absolutely killed there, and that's got us a master service agreement with MGM Resorts. Last year we did 9.2 million as our gross revenues, and it's interesting because my team, we have 80 people, in the company, technicians, their sales and everything. Like my sales and everything, no one comes out of HVAC. Actually, none of my none of my technicians. I've trained them all because I knew we were going to be completely changing HVAC, and so I was curious to see what would be the effect of HVAC is a it's been the same. It's never innovated. All right. Like it is not innovated really much. I mean, there's been something, but not really.
Right.
And it was interesting because we had, with our small sales team and stuff, we just started walking off the streets. I mean, personally, I'm just going to everybody, going, "Hey, let me talk to you." Like the engineer at Charlotte with Bank of America. Let me talk to you about your coils. And it was interesting when I did his air handler. I delivered a 65% pressure drop.
Wow.
That's when I knew I was onto something. Because the first time I was like, I didn't know anything. I didn't even know anything. But once I realized I was 100 air handlers, this is the HVAC system, and then I delivered a 65% drop, and I'm like, whoa. What we have been doing right now is actually been kind of going building by building, winning over the engineers. And let me tell you how hard it is to, these guys have seen and heard everything because things don't change much, in HVAC. So it's interesting because no matter where Blue Box goes, it sticks. And it's so easy to show and prove. And first I explain the process. It's a 30-second pitch. And the engineers get it, how the airflow brings it through. Then you show it to them, they pop it through the coil, and then we show results. And our results are immediate. And I'll give you an example. I did an air handler by myself. I was ambushed by these engineers because they're like, "Hey, we heard about your process, and we want to see a demo." Well, it turns out this system, it was actually another GM plant. And because when I first did this at GM, I didn't go after GM in the early stages because I'm in Southern California. Quite frankly, I was the only donkey pulling that sled. Like they were paying, to deal with it in a given day. But so I got this call a couple years ago from GM, and I go to this plant, and I had just developed this version of the system where it's very compact. And they said, "This is a monster 75,000 CFM air handler." And it was completely impacted with tar, or hydrocarbons from the manufacturing process. And it was running at crazy pressure. Like pressure where I was like, "God, is this motor gonna blow up like while we're here?" It was kind of like nerve-wracking. And in 4 hours by myself, I restored this thing back to, it was running at 6.8 inches of water of differential, which is one of the highest readings I've ever measured in an air handler. And in 4 hours, I dropped it down to 1 inch. And that's sopping wet. When the thing dried out, it dropped down to a 1/2 inch. And that's a 95% reduction.
And this was from their own manufacturing process. Like it was.
Yeah.
So I mean, your process even
So
works.
you can show the point of that is that you can show the result. It is immediate. I mean, and it is so. And sometimes we'll shoot coils and you don't see a big drop just because the coils are just not that bad, all right? Like not all coils are disaster zones. But the vast majority are.
Right.
And they'll refoul pretty quick.
Now, if people are watching and they're like, well, good, I'll just go out to my coil right now and I'll find some enzymes at the hardware store. Your process is protected.
It's patented, yeah. And what was interesting is I have actually 2 patents on it. And it's very broad. You know, when you do patenting, let's say, if I try to patent something in AI, you know, artificial intelligence, et cetera, I might be able to get a small sliver of intellectual space. And by the time I'm done with the patenting process, the innovation has changed so fast anyhow, like it's, you know, whatever. It's interesting in coils is because it's almost like this forgotten space that no one is thought. So I went in the patent on it, and this is wide open. There's nothing in there. And so I was able to patent, basically, put it this way, if you sneeze on those coils while it's on, I probably got a case against you. Right. It's very broad, wow. Okay? And I'm filing more patents because there's other innovations that are coming from behind this. But to your question on the investor side, we've been growing very rapidly and positive cash flow. I mean,
unlike most startups that have to build a factory and manufacturing, you guys basically...
So it's interesting with this system, our costs all in to build this is $500 to outfit a technician. One of the cool things about this process is if you have a big area, so this area, like imagine the General Motors plant again, where it's a monster system. Now these guys had tried pressure washing this system. They tried everything. They had pressure washers in there for days, probably a few weeks, trying to solve this problem and they had already allocated $250,000 to rip and replace. Now, when you pressure wash these giant systems, you have to shut the system down and all that. They are probably, every time they try to treat it, probably pumping 1,000 gallons, if not more, into, you know, trying to clean these coils and getting just that 5%. When I did that thing at GM, if I used 25 gallons of water, because it's a big system, I'd be surprised. Most systems, it's, you know, this is 7 gallons, you know, that's good for, you know, 7 to 10 gallons. We barely use any water. It is so water efficient, it's crazy.
Now, can I just ask, let's go back to enzymes for a second, because, you know, I'm pretty doltish when it comes to this. Sure. Why not just bleach? Like, why not just kill whatever's in there?
So it's because I'm keeping the systems on. All right, number one. Number two, bleach is not going to remove biofilm. All right. Now it may kill microbes, etc., but not the biofilm. So the biofilm is like I said, it's this membrane that forms inside. That is the core issue that forms, and what it is like sticky paper. So when and these things are constantly moving air through. So if there's a dust particle, hydrocarbon particle, any kind of thing, it starts sticking to it. And then what happens is deep inside is then it starts creating blockage and it grows.
So even if you somehow could kill every living thing in there, you're still leaving the blanket behind.
And so this is where enzymes, this is where I start thinking about, I'm like, you know what? I can't nuke it with chemicals. It's got to be somebody, it's biological. And again, it was kind of a first principle thing. I'm like, it's got to be somebody's food source. You know, and this is where enzymes just, now the thing is, because I keep the systems on, what I knew with enzymes, I can make it so it's completely odorless. And that is really key, because we're going into, now we're doing, like in hospitals, we're now doing some of the top leading medical institutions in the United States, like MD Anderson, Sloan Kettering in New York, UCLA Medical Center, it's a laundry list. And we're going in middle of the day, middle of summer, no downtime with the system, and we're doing cancer wards, intensive care units, and no one can tell we're doing this while we're doing it. You can't have any kind of odor, because people freak out when there's a thing. And this was part of the thing I had, that was the big event. And the nice thing with the enzymes is, I tell my techs, if you get it on yourself, you're probably gonna be better for the wear. So it eliminates all the risk. You don't damage the coils, the metals. It's impossible to damage. It goes straight down the drain. There's a lot of,
all right, so get back to the investing part. So I want to know how to invest.
So we are looking at doing, I'm now looking at doing a raise. We're probably looking at like, and it's not going to be a huge raise right now, but probably like at $10 million.
Just to kind of scale the company even bigger?
Yeah, because like I said, it's not capital intensive. And one of the things is I want, listen, I think all your investors can appreciate too, most startups die of indigestion, not, of starvation. It's, you get too much money too fast. It's like all of a sudden you have to hit everything. Now I intentionally avoided raising, we raised some money, but not a lot. We never, I've kept this resource kind of depleted, so we got good at what we're doing first, and now we can start scaling. So the next round is, like a 10 million round, and this is primarily because this right now is Blue Box 1.0. This is our manual process. We have technicians in the field, and they're executing, and they can do any type of system. The new raise is actually going to be primarily for Blue Box 2.0. 2.0 is we're actually automating the process. So you take an air handler and you put this framing system in, and you have a foaming bar, and it goes up and down, and it injects the enzymes, and it does it automated. So now with 1.0, we have a technician. So the question becomes, how often should you treat? We get this all the time from the engineers. And we typically start everybody off at once a year, and they're used to doing 1 year annual PMs or preventive maintenance programs. And give you an idea of like our pricing, on this, because I price this. So if you're to say contract out with a Johnson Controls or like one of the large mechanicals to clean your coils, that's, our pricing could be anywhere from $500 for a small air handler to $2,000, $2,500 for the big monsters. Our ROI, depending on on the GM case, it was before I left the building. Okay. Well, I put it this way: like with GM, it was right there on the spot. I saved them $250,000. Right. But on the energy, like the pressure drop was so massive. Their engineers estimate just in that one system, just on airflow, we saved them $50,000 for energy consumption for the year, okay? That's not even going into chilled water effect.
And that's not even going to health.
No, it's not going to health.
I don't even know how you count that, but I mean, it's got to be.
The ROI on this thing it's one of the easiest ROIs. It is the lowest hanging fruit you can find in any building. And what is interesting in buildings is that that buildings account for 40% of all global carbon emissions.
Wow.
All right. And, I said the HVAC system is the #1 energy consumer, in those buildings. And here's another crazy statistic. And this actually comes from Bill Gates, from his Breakthrough Energy Fund, it is anticipated that the world is going to add 2 trillion new square feet of building space by 2060. 2 trillion. That is the equivalent of adding a New York City every month for the next 40 years.
Oh my God.
Okay? What happens when you have, right now the world has an estimated population of about 2 billion coils, okay? Think about market scale. And that population is estimated to grow to 10 billion plus by 2060. And here's one of the sad drivers of this market is that as the world gets hotter and hotter, it is driving demand for more AC. It's becoming this vicious, and more AC you get, the more carbon emission you get. It is it's a disaster, kind of thing. This is one of the things, like this, what we're looking to completely change.
Are there any thoughts of working with manufacturers?
So, 2.0 is going to be, we're going to retrofit, and essentially we're going to come in, we're going to install these systems at our cost, all right? And then it's a question of, do you want your system cleaned quarterly, monthly, weekly, daily, hourly? So like hospitals, and different operating environments can have different parameters or needs. Like, think about operating rooms in hospitals. This is where you want those coils disinfected before every surgery. I'm going to tell you right now, if doctors had any clue of how bad these coils are, feeding their operating rooms, they have no clue whatsoever.
Right. It's out of sight.
It's out of sight. And, you know, in a hospital, you have your doctor-patient, or the, you know, doctors and patients and nurses, that universe, and you have your engineers. Those two worlds do not collide. They don't even know each other's language.
Right.
These guys have to keep the systems going 24/7. These guys have to keep the bodies, you know, people alive 24/7. But, you know, you know, if they had any, you know, and you know, listen, the engineers are not trained on biology. So when they see, we literally see stuff oozing out of coils. Like, it's that bad.
So in a room like we're in now, a typical hotel room, can your system clean the coil in this room?
Oh yeah, absolutely. And it's interesting. We did actually 1,500 rooms at the Mauna Kea and the Hapuna in the Big Island just before COVID. And you know, in Hawaii, because it's humid and microbes love to grow, you know, in that environment. So they had these units that are up in the ceilings, completely hidden. And it's interesting because in HVAC systems, like they're very small, they're in the ceiling, and they're actually designed so you can't get to the coil. The systems are sealed. You have a blower that blows air into it, and if you want to get to that coil, you have to dismount the motor blower. I mean, it's a full day job for one unit, to the point where they were ripping out all the systems every 4 years, every 4 to 5 years, and just rip and replace. Okay, massive amount. With this system, it's interesting because we can do any small coil. It's very controlled, and so I developed this technique where you just pop a hole, you drill a 3/8" hole between the motor and the thing. Take an endoscope, peek at what the coils look like. Let me tell you what those coils look like. It's black mold.
Wow.
It's disgusting. So when you walk in a hotel room and it smells funky, it's not the carpet, it's not the walls, it's your HVAC system. And there's a picture that one of my salespeople, they were at a hotel, he pulled off the filter on it. It is shocking. It is a microbial war zone. It is the most disgusting thing you've ever saw. I have pictures of air handlers that are feeding surgery units that have mushrooms growing out of them.
Oh my God.
Okay, and that's what's on the outside. That's the easy stuff to get to. If it's growing mushrooms, you know, what's going on deep inside. So at the Mauna Kea, the Hapuna Resort, we did 1,500 rooms, and we were able to knock out a room in 20 minutes. You just go in, pop a hole, take the endoscope, foam it out, boom. Now these systems are like small systems. They're running at about 600 CFM is their original design. All of them were running about 150 CFM. So no airflow. And their exit temperature, the air coming in, Hawaii is always 83 degrees. No matter what time of year it is, it's 83 degrees. The exit air in these systems were 78 degrees, 74 degrees, around there. When we were done, the exit air was 62 degrees.
Wow.
Completely changed. And what that does, think about a hotel room where you set it, you want it nice and chilled in here, and it's running nonstop because it can never hit set point. Yep. If you have it at 63 degrees, it gets cool, this system turns off, and you're talking millions of it. Now, what is interesting, what we're really going after actually with, you know, air today is like what water was, let's say, in the 70s. You're not going to remember this, Jess, but we do. And before it was bottled, before it was branded, all right? You know, the average American spends 90% of their day within a climate-controlled environment, all right? And you think about like hotel rooms and Starbucks or restaurants or any kind of business that, you know, with retail clients and stuff. And it's interesting because I actually see air as this whole new opportunity to, like, would somebody want to stay at the Bellagio? You know, the Bellagio has the cleanest, most energy efficient air on the Strip because they've been doing blue box for the last 4 years. The only people who know that are the engineers. No one else. And, you know, I'm trying to talk to MGM, you know, with COVID and stuff. Listen, they got other issues. But the point, the hope is like, but we're also dealing with Marriott and Hyatt and stuff. we're solving technical problems, but there's a massive opportunity because air is one of these, like, it is one of those issues where, you know, like we see it, and also we want to make it front and center is as a story, you know, the carbon effect of air and then the indoor air quality. Because of COVID, it has completely changed the world's perception, or is creating a heightened awareness of air. And with that, you know, we see this as a massive, like, I see an opportunity for Blue Box to be able to brand air where we are in outside, like, most validated buildings healthiness, you know? Like, they're, now it's interesting because it's,
right. I mean, where do you want to have your surgery today? Do you want it at a Blue Box hospital or not? Like,
yeah, and so it's interesting because Trane, which is the largest manufacturer of HVAC systems in the United States, #2 in the world, Daikin, which is the #1 manufacturer in the world, probably #2, #3 in the United States, they both are sending outsourcing projects to us to solve their coil problems. Now, Trane's engineers have spent the whole last year studying Blue Box and our process and everything. And they just came back to me actually just 2 weeks ago, 3 weeks ago, saying, all right, you got the best process on the market. You solve, you know, this big problem. And it's interesting because I was a little nervous on talking to Trane on that because they make a lot of money selling, you know, new coils and stuff, but it's interesting on the issue of climate because they're under a lot of pressure from their massive clients on how to make the HVAC system more efficient. Cleaning the coils, you know, first off, it's the key, you know, to the entire thing. And so on our capital raise, you know, the objective is to start scaling. You know, really start building upon, you know, what we've done, because what we've done is built up this remarkable client base. Like, we've got market validation, we have market fit, all right? There's 2 billion coils in the world, and this is the only process that can, you know, and cleaning coils like cutting the grass. You know, it's a repeat offender. It just, you know, it's recurring revenue, and so we see this as we see this almost as like, are we kind of entering a S-curve adoption? Because right now what is happening is we meet with a company, a facility, we start solving their problem, it's land and expand. We now need to take this conversation up to the C-level and start going enterprise as a, you know, as a solution, you know, and obviously we got to resource up, make sure we have the infrastructure in place to, you know, be able to do that.
I wanted to ask you, I mean, in the future, will I be able to go to a hardware store and buy a can of Blue Box for
so
my
it's
home?
kind of, you know, it's kind of funny. So we actually have, I just developed our first Blue Box in a can. It's kind of funny. We'll get it in mid-August. It is, right now, it's meant for like in hotel rooms, and for our clients, like at MGM Resorts, I see them buying a ton of these for the rooms because they have their people in the field, and so we do the service right now. We have technicians and stuff, and we've been keeping it in-house right now because I want everything done. We're trying to prove out the technology, and, you know, I want to make sure everything is done per, and we're collecting all the data and stuff. So the can is for like these, let's say, refrigerators, you know, like the window units and things like that. Yeah, the answer is yes. I guess, you know, the first cans we have, we'll start going to our engineering clients, and so, you know, they could just treat some coils.
So how can I get on this next round? I mean, come on, tell me how I can. Well, yeah. Is this going to be for accredited investors only? Will it be just for VC firms? Like, what are you thinking?
Well, you know, the objective of this next round is, I mean, it's interesting because it's not really about money. It's really about I'll be quite frank. Actually, part of me is you know, we have a great story on this. You know, I know it, but no one knows about this. Right. You know, I reached out to you guys, you know, because we have a bunch of projects in Boston, and, you know, it was Friday night, and I was watching your guys' show, as I always do, and I just thought to myself, I'm like, you know, I should email these guys. I guarantee they'll dig on this thing, and the part of the raise, what the objective is I'm curious on what the reception is to the story, and, you know, am I looking for a pure VC? Is it more institutional, or part of it is about how to, like, how to start aligning the right type of people.
Right, how to grow properly.
Because you know, like what I see is we're going to raise 10 million now. Then the question is, we're going to raise a whole boatload because there's a 3.0, and 3.0 is really interesting because 2.0 is already developed. We're actually installing our first system in Dallas into one of the main hospitals there, and this is going to automate it. And what is interesting about 2.0 is that, so like for example in Massachusetts, one of the reasons I'm out here is that they actually have, the utilities are rebating coil cleaning, which is surprising because utilities typically do not like to rebate a service. They want like LED lights, you know, you pay for it, install, rebate it, they can calculate the energy efficiency effect. But in buildings, there's all this, like how to make buildings efficient because it's 40% of all carbon emissions, and LED has already been done. And that low-hanging fruit is out of the way.
Have to find the next one.
Everybody's looking for these nominal little fixes. And it's interesting because the utilities here do not know about Blue Box yet, but they were like, all right, we know that even if you splash some water on it, it's going to have some kind of effect. And they're just looking for anything. They have so much money to spend.
And I mean, you're hitting at the peak time. So when a building needs power in the middle of the day for air conditioning, you're reducing that load.
Exactly. And so this is where 2.0 is meant to. Now we're already getting rebated, like around the country. We started like in Louisiana. We have Entergy has been rebating Blue Box. I think it's like 75% of the costs for clients. Now,
so I mean, that's a no-brainer then.
It's been a no-brainer, but it's with 2.0, it's an installed base. Mm-hmm. Here's what 2.0 makes possible, because when we do it with 1.0, a client, you know, let's say, you know, they spend $20,000 or whatever to clean their building, they're going to get a very quick ROI. But what happens is the pressure is up here, then it drops, but then it starts to build up, right? So this is all energy waste. 2.0, we're going to drop it and we're going to guarantee it's a flat line. And that changes everything. You know, in all of a sudden then it starts becoming interesting because it's like indoor air quality, like you know, hospitals now can disinfect their facilities, you know, constantly. Indoor air quality, the effect on chilled water and everything, and I said most buildings have 40% more excess capacity built into it, you know, because we're going to bring it down always. And here's the beauty of it is, I tell these engineers, you know, I went to Apple's headquarters. I talked to their engineers. They absolutely love this, and I go, guys, you just spent what, $2 billion building this spaceship? You clean your coils once a year with Blue Box, you'll never replace a coil in your lifetimes, and I'll guarantee it because it's a brand new building. I get come in from, you know, thing, and you know, it's this ability now to always keep them at peak efficiency. Right. Yeah. So on this first round, it is a. We'll see how it evolves. You know, they said I really haven't. I've talked to, you know. There's people that have been watching this, and they're, you know, I'm getting emails every week. When you raise money, when you raise money, and I'm like, they're gonna be a house over here, guys. And you know, so it'll be interesting because you know, what are our objectives on this first round, and then, you know, what does, you know, the second round, if we need to even do it, you know, looks like. At this stage, I'm looking to start telling the story, and you know, what I'm really looking about is like, who are people who can really help add value to Blue Box? Mm-hmm. You know, because listen, the world is loaded with money. I mean, there's so much money out there, it's crazy. What the world is not loaded with is really innovative ideas. What is remarkable about this, you know, this story with Blue Box is that where can you find a problem that is universal, that is global, that
no one seems to know about,
that no one knows about? It's a singular choke point of every modern building in the world. It's a repeat problem, like it's a continuous operation flow problem, great margins, you know, all these things, and it just it checks off all the boxes. It's a hard thing not to like, you know.
It really is.
I mean, listen, I'm doing the cooking here, so I love it, you know, how it tastes. But it's, you know, what I'm telling everybody is like, everybody gets it. I mean, it's you guys got, when I just gave you that, you know, intro, it piqued your interest immediately. And you know, it's easy to understand and relate. This is not, I'm not designing a new semiconductor chip or creating a new, you know, supercomputer. I'm not trying to solve full self-driving, you know, like kind of problems, you know, and how to deliver, you know. But Blue Box can have it's interesting because we already know for a fact that Blue Box has the ability to have an effect on global energy consumption, carbon emissions, and human health. And we could do it easier with a fraction of the capital and a fraction of the complexity of what Elon is trying to do, you know, with cars. You know, it's...
You know, government could get involved here, just like the utilities, and they could say, you know, here is a tax incentive if you'll get your system cleaned. You know, I mean, it's just that simple. Because
absolutely, it's a, once people really start, what we need, once people, you know, I'm dealing with the engineers and the buildings, and they get it. You know, I'm not even selling energy efficiency to them. That's the beauty, and this goes back to 2008 when really what I was looking for is like, what if you can make carbon reduction profitable?
Right. And
if you make carbon reduction profitable, you make it possible. Every company in the world wants to reduce their carbon footprint. It's a question of how. That doesn't require massive capital expenditures, and then how can I make Marriott hotels sell more hotels? It almost, you know, like
it almost
while
seems
reducing their footprint.
This should be tied in with carbon pricing. Where basically, if I'm Marriott and I pay for this and I'm going to reduce by a certain amount, it's like I get carbon credits because that's what I just did.
Absolutely. All the engineers understand the energy efficiency effect. We're not really selling that. Right. You know what we're selling is we can get through that coil. Right. And we're selling performance. You know, like all of a sudden that room is cold. Right. You know, we're selling that you don't have to rip and replace that coil. Like it's you know, equipment extension life. There's all these other things. Now, what we need to do is really get the data, and we've been collecting, I mean, troves of data on this. But the idea is to really get this down to a mathematical formulation where, you know, it's the data's there, so it's almost under scientific review, kind of like to validate. Because once that hits, then you definitely can see, you know, governments and everything looking at this like, all right, this becomes a new standard and everything like that.
Yeah, I can totally see, you know, 5-10 years from now where this is just built into. Of course, this is how we're going to deal with carbon reduction. Yeah, you know. Yeah, and it makes sense. I mean, you maintain your vehicle.
Well, it's you think about, like, you know, what they say, what Elon's doing with vehicles, and, you know, he's trying to, you know, accelerate the world's pathway to sustainability, and you know, it's, you know, he's disrupting the industry. Like what he's doing is, you know, whoa. But it's interesting because, you know, like that's transportation. No one is looking at air, and air is the foundation of the modern world. And it's interesting because Las Vegas would not exist without air conditioning. Dallas, Orlando, you know, like Singapore, Hong Kong. Like, it's interesting because it's one of those, it is the core foundation of the modern world. And it's getting hotter and hotter out, which is driving more and more demand. And it's this, you know, vicious cycle. Now there's a way where we can change the slope from like this and increase cooling demand, because we're going to have to, you know, deal with that, but have a pathway where it takes less carbon. And then, you know, you said it just, you know, and it's scalable.
And I want to go to vehicles for a second. There's air conditioners in vehicles, and there's air quality. You're going to spend hours every day in your vehicle, and if you're just blowing that through the same dirty coil. So I'm just wondering again about the spray can. Like,
so like vehicles are kind of a tricky little. I've gotten that question quite. Is a little tricky because it's like, how do you get access to the coils? Because the way they, you know, you build them so they're typically inaccessible.
But I mean, I wonder if during a typical, you know, a regular servicing or something, if the mechanic can get in there and
yeah, it's what I've been told. Like, listen, it's just the way cars are designed right now. It's almost
a sealed
like
system.
It's a sealed system, and that's somewhere.
All right, so Elon, if you're watching, we need to have a little hole for Blue Box.
Well, no, what they've done with the, like the Octavalve and made, it way more efficient and everything like that. No matter how good the filters are on it, it's going to load up. Right. And it's but now it's solvable. Yeah. And that's the thing that most people, I was telling you, like the worst coils in the world are hospitals. The second worst, schools.
Wow.
And it's kind of the same reasoning because, kids are little walking petri dishes, right. So you have 40 kids in a classroom, that air is recirculated, and it was, and we're doing a lot of schools. So we're doing Clark County School District, fourth largest in the country in Las Vegas. In Southern California, I think we're about to do like Burbank, and there's a bunch of schools in Virginia. We're doing school
you're probably
districts.
Saving them a lot of money.
The efficiency gains, the improvement of indoor air quality, the extension of because schools are always resource constrained. They have to have their systems lasting for a long time, and now this just makes everything easier. I mean, just the fact of you can now extend the life of these systems by a factor of 4, if not longer. The world spends $130 billion a year on new HVAC systems.
Wow.
The majority of that spend is to replace coils. And you think about it, this is a 100-year-old problem. You know that since the invention of the HVAC system over 100 years ago, there's never been a way to clean these coils. And what the industry did is engineer around the problem. Right. And, and it's not a bad thing for the manufacturers if you got to rip and replace.
Right.
And the mechanicals absolutely love it. And, there's never, I don't know, it's kind of weird. Like, to me, it's odd that this problem even exists. But it is one of those classic, it's a back room, but it touches everybody's life. 90% of an average day, you're being affected by a dirty coil, right. Whether you know it or not. Unfortunately, I ruin most people on air once they, done talking right. to them because they never think that, all of a sudden they're like, what's the coils looking like?
Well, I think what I want to do is I want to go and see what companies work with, and that's how I'm going to choose what hospitals and what.
It's interesting because I actually have friends of mine. They all ask me, they're like, all right,
where should I go?
I'm going to this place. Have you guys, when's the last time you've been there? I'm like, and it's true. I mean, what's interesting? There's a hospital we did in Southern California, not going to name it, but they had an air handler, give you an idea of the effect this can have in especially a medical institution. They had a big air handler, 50,000 CFM, which is, like 12 feet high, 15 feet across, a big system. And this one air handler was feeding the 3rd floor of this hospital. And it had developed a rare fungal species deep inside the coils. Oh, God. That it was spewing spores, okay? And it was aspergillus, which is, I don't know if anybody knows fungus, you don't want to be near aspergillus. It's a killer. And it shut down this entire 3rd floor for a year. Now, it's really funny because I pitched this engineer and he goes, this is awesome. Can you guys have your guys here tomorrow morning, 8 a.m., give me a price. I want to, have a full project done. And he didn't tell me the problem. And I go, you know what? Yes, we could be there at 8 a.m. And I'm going to come down there and personally shoot this thing because I know there's something going on and I'm not going to dig too deep. But so we shot this coil. And then he's watching the whole time and he goes, this is great. Unbelievable. Shoot it again. Full price. I was charging him like, I think $2,000 a pop. And shoot it again. He goes, one more time. And so we did 3 cleans in one day and I'm like, what the heck is going on? And he goes, this is fantastic. We dropped the pressure tremendously and all this stuff. And he goes, I got to get equipment list. I'll get back to you. I got to get budget and all this stuff. A couple months later, I talked to, I'm talking to this gal who is an industrial hygienist. And I was explaining Blue Box. She goes, I know who you are, and I know Blue Box. And I go, really? And this is in the early days of Blue Box. Like, no one knew. Like, this is, probably in 2016, maybe 2017, where she goes, you're doing the XY, hospital, and she goes, I actually have been monitoring air handler 17. I'm the industrial hygienist for that. And she goes, Tom, the engineer, he goes, he didn't tell you what the problem was, did he? On that system. And I go, no, but I knew there's something going on. And she explained to me, is, you know, it has aspergillus in it and is closed down things. She goes, I tested that system 3 days after you treated it. No more spores. You completely solved the problem. 2 weeks later, I opened up the third floor. Wow. And I go, really? I go, because I'm still waiting for that guy to give me the equipment list for, you know.
Wow.
Yeah, yeah.
Yeah, and I think that speaks volumes. The fact that you have clients that seen with their own eyes that it works, and they sign up. I mean,
once they see it, it's interesting because so you know, we're in this stage of, you know, because no one has this budgeted, you know, so you have to get budget and stuff. That what happens is we go into place, we start solving their problems, and then we, you know, try to help them go get, all right, let's go get budget, and then every year each client, like, our revenue is just, and it's repeat, you know, and so then so we have this really robust, you know, pipeline going, and like I said, everywhere we go, it sticks. And Disney World, we actually just landed Disney World a few months ago, and it was funny because it took a while to get the demo going, but then once they saw the demo was on Wednesday. They gave me a PO for, I think it was $25,000 on Thursday. And they're like, you better be here Friday. Now, wow. Disney World has 8,000, I estimated probably 6,000 to 8,000 air handlers throughout the, you know, it's massive, you know. And in Florida, it gets gooey down there. You know, every building smells like a wet dog. So you imagine like what's going on in those coils. And it's, but it, you know, once the engineers see it, you know, then he kicks in overdrive, and then the next step is just, you know, helping them build budget. And this is what they're doing right now. We're solving their problems, but you know, they're already looking at this. Probably, you know, this will be their standard practice, wow. Just Jim, like with everybody else.
Thank you so much for inviting us to talk to you today. This was just mind-blowing, and eye-opening. So thank you for sharing this with us and our viewers. This is, I mean, I think we're going to get a lot of interested people. If people want to reach out to you, what's the best way to get in touch with you?
I give you guys my email, and you know, it's jim@blueboxair.com is the easiest way.
And if there's businesses out there, should they just go to your website?
Yeah, you go to the website. There's just go to info, and yeah, that would be the easiest way.
And then I'm just thinking, you know, investors, I know I'm going to get a lot of emails. Yeah. I think we're probably going to want to talk to you about setting up some kind of, I don't know, fund or something that we do to make it easier for you to onboard. But like, let's keep talking.
No, I mean, listen, it's you know, what I love with your guys' show is, you know, it's you know, it's not just about Tesla, it's about, you know, how the technologies that really, you know, it's like a lot of futurism, you know, and how to use innovation and, you know, change what's being doing, you know, first principles, you know, and, you know, we got a big problem to solve, how to solve it. And my guess, you know, I'm sure you, I mean, I know you guys know, but your viewers are, you know, listen, the companies that decarbonize the future are going to own the future. Yes. You know, so it's, you know, we're gonna have to change everything to how we're doing about it, and it's, you know, it's you know, one, there's a lot of money to be made in that. All right. Two, it's a, you know, it's like a passionate group of people who actually care. This is not, you know, like, let's say I go raise money, you know, from different groups where it's like they're just looking at ROI and they don't really care what the thing is. You know, I want people who care. You know, it's you know, it adds more value actually. It adds, you know, it's a better, you know, type of, and this is, you know, I think so.
Yeah, absolutely. We get it. Thank you so much, Jim. This is
thank
awesome
you.
to meet you.
It's a pleasure meeting both you and Jesse. It's been a lot of fun. Thank you.
Wow, I know that was a long interview, and I thank you so much for sticking with it. It's amazing what a simple little problem like, oh, there's just gunk gumming up our air conditioners that we've ignored for like 100 years.
Well, and it's a problem that's built into air conditioning. Right. Like they've known about it since the beginning, and the way they've solved it is like, well, just oversize it. That'll take care of it.
And the only like real solution would be to like add filters. And if you add filters, sure, you might be fixing like the health impacts of it, but you're not going to be solving the performance. In fact, the HEPA filter that you're going to have to put in front of the coil is going to be, you know, reducing performance of the entire coil anyway. So, I mean, enzyme cleaning is like the only way to go, and Blue Box has the patent for it.
Yeah, and I mean, we talk a lot on the Now You Know channel about the CO2 ramifications. I mean, we're talking about, 500 million tons of CO2 saved if Blue Box was used on all compressors on the earth today. But let's just talk about one thing that I don't think is even really we wrapped our head around in this interview. If my brand, if let's say I'm Marriott Hotel, and if I can label my rooms as Blue Box Clean, what do you think is going to happen to the competition when they're like, oh wait, so if I stay at Hyatt, then I don't get the clean rooms?
I can't believe that this is such a pervasive problem with such a disgusting looking image. I mean, some of these coils look absolutely disgusting, and to think that like air is flowing through them and then is going straight into where you are living.
How about this? What if a law was passed that you had to show pictures on your website of your compressors, updated every month so that people could see the cleanliness of it? I think if we saw what you were, the rooms you're about to walk into and what you were going to breathe, that would have a huge impact on how well they were cleaned. And the problem is right now, even if they want to clean them, as Jim pointed out, what are they going to do? Walk into your room with a pressure washer? They can't.
And this is why it's so disruptive. I mean, HVAC has not changed in 100 years at all, like pretty much at all. You look at some of the oldest air conditioners in the world, they look almost identical to the ones that you have today.
And in fact, refrigerant only changed because we had to change it because it was killing our ozone.
Right. So, I mean, like, take an example like that. The only time that it has changed was when there was like a big, massive problem.
And this is a big, massive problem.
This is a huge problem, and one that we've just swept under the rug for way too long. Jim talked to us a little bit after the interview. We went and had lunch. It was very interesting.
Yeah, and I just want to talk about a reason you might want to join us on Patreon. You might not have heard about this if you're watching Disruptive Investing and you don't watch our other channels, which are, Now You Know. We have a Patreon, and on that we have an investor club. So at the $10 level per month, you can join that. We have over 1,600 members at the moment. And there we get to talk to all of these amazing CEOs and founders every month. But beyond that,
and we talk to them on Zoom, and you can join us.
Right.
You could actually ask a question to Jim, and he might actually answer it. So, I mean, that's one reason to join Patreon. Another reason is that you would get to see this video a little earlier.
Yep, and we have a Slack channel where all of our members can talk to each other about all these amazing investment opportunities before everyone else gets to hear about them. And then lastly, we were talking to Jim, and we were talking about his next investment round. And, truth is, most companies that are doing really well and that can get money from anywhere don't really want the hassle of dealing with a lot of little investors like us, right? So I talked to him about maybe we could put together a fund and gather a bunch of other small investors so that it becomes a fairly large fund and invest in his company, which is something that starts to interest someone who doesn't want to deal with like hundreds of small investors. And that's the kind of thing we can offer to you guys here on our investor club. So if you guys are interested, head on over to Patreon, join the investor club. Let's talk about it on Slack, and let's figure out if we want to go to the next step with this.
Thank you so much for watching Disruptive Investing.